So I want to tackle one of the other problems I give to students in my when they're learning array lists, which is the isPermutation function. And I like this one because unless you know how to use hash maps, it is an extremely dirty to write function. It's fairly straightforward. It's kind of the idea, which is I need to check everything against everything else and make sure they have the appropriate amount of everything occurs the appropriate amount of times. But it's actually quite tricky. So it looks like a mess. Now that I like revisiting now because if you have a hash table, if you're willing to sacrifice some space, you can make it a heck of a lot less messy, and you can also make it run really, really, really fast. So it returns true if the lists are permutations of each other, and false if not. So what does that mean? For them to be permutations of each other, then they have to have the same elements which occur exactly the same number of times. Right? So for two words to be permutations of each other, for instance, right, rather than lists, if we were dealing with strings, for two strings to be permutations of each other, then the way that would work is that, hey, if basically they had the same count for each of the letters, right? If word A, you had L occur twice, H occur once, E occur once, O occur once, right? And word B, you'd have L occur twice, O occur once, E occur once, and H occur once, right? Right, two different words, right? But they have the same letter counts, then that's great. Because that sounds kind of familiar to our word count problem, right? And that's exactly what we're going to use here to solve that in a much easier fashion. So what we'll do is that we'll generate a essentially word count for each of these two lists, and if they match, then they're permutations, and if they don't, they're not permutations. All right, so let's go ahead and see that. Public static boolean is permutation. It's a list of E's, list A, list of E, list B. So we've got those. It's public static E. Boolean is permutation, right? So this one is actually fairly straightforward. Again, first, if list A if list A dot size is not equal to list B dot size, return false, then they're not permutations of each other. And again, we're just going to assume they're permutations of each other until proven otherwise. So we'll create one map A. So map, and again, this is going to be a count, so of E's to integers, right? So why E there? Because it's a list of E's rather than in this case, which was a list of strings. New hash map. And map B is a new hash map. Okay? It's a map where the keys are the things the things in the list, and the values are how many times that thing occurred. So let's go ahead and get started with it. So for E item in list A, and we'll want to do the same for list B, so I'm just going to go ahead and copy paste that over here. Okay. For every item in list A, if map A dot contains key item, so if I've not seen that item, or I'll flip it around, if I've seen that item already first, else, right, we can do it either way. So if I've seen that item already, I'm going to do something, but if I haven't seen it yet, right, well, this is the first time I've seen it, so map A dot put item, and the number of times I've seen it, into the 1. Then map B, sorry, map A, let's see, int times scene dot, is equal to map A dot get item. Right, so if I've not seen it, right, I put it in and saying I've seen it once, otherwise I get the number of times I've seen it, and then I go map A dot put item times scene. Right? And then I just do the same thing for, yeah, I'll go ahead and copy it over the same thing. Now I just do the same thing but for list B. So list B, if map B contains the item, map B contains that item, then get it, put it in, and some of the more astute of you may have inferred that you can in fact, oh, I made a mistake. So some of the astute of you may have inferred that I have made a mistake there, which is that, right, again, if I've went over here, map A dot get item times scene, put the item and increase the number of times I've seen it by 1, right? And same thing over here. Now the more astute of you may have noticed that, hey, why can't I just do this over here? And you totally can. Right, where if I haven't seen it, I say I've seen it once. Otherwise, I say I've seen it the number of times I've seen it plus 1. So now, let's see. How does the dot equals method work? It's a great question, and we should never make assumptions about that. So let's go ahead and look up hash map equals Java. Right. So the equals on it is let's see, apparently according to Stack Overflow, it's equal to double equals because it does not override dot equals. It's just simply the equals method that is just generally used. They check to make sure that the maps are the same objects. So what we'll have to do is then go for each E item in list A, in list A, we're going to go over map A dot. So we're going to go over all the words we've seen, sorry, all the items we've seen in map A. Key set. If, let's see, if map A dot get item is not equal to map. So if the number of times I've seen this item in map A is not equal to the number of times I've seen it in map B, or rather list A and list B, return false. And then we just do the same thing for list B, just because you can't guarantee, because for paranoia we don't want to guarantee. So then for every item in map B, if it wasn't in, if the number of times I've seen it in the first list isn't equal to the number of times I've seen it in the second list, return false. So that's isPermutation, and it's unfortunately, again, it's about as long, but it's a bit cleaner. And it's also, again, much quicker. Each of these operations took O of n time, assuming A and B are the same size, which they are because we check. So that's, again, an O of n time algorithm versus the O of n squared that you're probably dealing with.